Next, I'm going to work problem number 25, whose instructions say solve the following system of equations by graphing. So remember, when you're graphing, you're using y equals mx plus b, where b is your y-intercept and m is your slope. So this equation happens to already be in y-intercept form. My 5 is my y-intercept, and my 2 is my slope. But remember, I like you to write your slope as a fraction when you're graphing, so it's 2 over 1, or you could say negative 2 over negative 1. If you don't have room to go up and right, you can go down and left, and that keeps you on the same line. Okay, so I'm going to start by graphing that one. My y-intercept is 5, so I go to 5 on my y-axis and put a dot. 1, 2, 3, 4, 5. That's my y-intercept. And now from there I'm going to do my slope. It was 2 over 1, so I'm going to go up 2 and right 1, and that's a dot. But remember, especially when you're using a graph that's as sloppy as my hand-drawn one here, on your test you'll have a graph there for you. My accuracy is not going to be perfect, so I want more than 2 dots to do my graph. So I'm going to do my slope, and I have nowhere to go up and right and still be on my graph. So instead I'm going to go down 2 and left 1, down 2, left 1, and I'm still going to do it even again. Down 2, left 1 more, down 2, left 1 more. Just trying to give myself some kind of chance to have some accuracy here on my graph, since my coordinate plane is far from perfect. Okay, next I want to do 5x plus 2y equals 1 and graph it, but it's not in slope-intercept form, so I need to get it there first. So first I'm going to subtract 5x from both sides. And that gives me 2y equals negative 5x plus 1. Then I'm going to divide by 2, just solving for y. So now I have y equals negative 5 over 2x plus 1 half. There's my b, which was my y-intercept. There's my m. And remember, I can name my m as negative 5 over 2, or I can say positive 5 over negative 2. Going down and right is the same thing as going up and left. It keeps you on the same line. Okay, so first I'm going to graph my b, which is at 1/2. 1/2 means halfway between 1 and 2. This makes it a little bit harder to do your slope because you're always working in between 2 ticks. So now, for my slope, I want to go down 5 and right 2. Down 1, 2, 3, 4, 5, and right 2. So I'm still halfway between 2 ticks. Now, I'm trying to figure out where I cross this line, so going down more is not going to help me get there. I'm going to go up 5 and left 2 and use this slope. So up 1, 2, 3, 4, 5, and left 1, 2. And there's my other point, which is, not perfectly drawn, but fairly, whoops, missed it by a little bit. You can see how difficult this is to get an accurate solution, because the solution is going to be where these two lines cross each other. So if you look at that, it appears to be happening right here, which is the point negative 1, positive 3. Negative 1, positive 3 is where the two lines cross each other, and that's the same thing as if I had solved these two equations using, for instance, substitution. It's the point that I would have gotten, the place where the two lines cross each other in the coordinate plane. Let's just check and see if, in fact, we do get that if I solve this same problem by substitution. Because remember, the method you solve by should not affect your answer. So my two equations were y equals 2x plus 5. I'm using this as a check. I certainly did not have to solve this 2 times. But if you've solved it and then you're not sure if your answer is right and you want to try by another method to check it when you're taking your exam, you certainly can do that. I'm saying that y is 2x plus 5, so I can go to this equation and replace y with 2x plus 5. So I have 5x plus 2 times 2x plus 5 equals 1. That gives me 5x plus 2 times 2x is 4x. plus 2 times 5 is 10 equals 1. 5x plus 4x is 9x. Subtract the 10 over to the other side, and I get 9x equals negative 9. Divide both sides by 9, and x equals negative 1. Go back and go to my other equation and substitute in the x that I got. I have y equals 2 times negative 1 plus 5. That's y equals negative 2 plus 5, which makes y equal 3, and my solution, ordered pair, is 1, negative 3. The same thing I got when I did the graphing. So, two different methods on the same problem. I used substitution to check my graphing. How else could I have checked that my answer was right? I could have, of course, have plugged negative 1 and 3 into those two original equations I had that I graphed to find the solution to, and if they made true statements, that would have checked it as well. So two ways for you to go here. That's it.